Hi, welcome to our channel Config the Network Academy. In this video we are going to talk about OSI model. When networks first came into being, computer could typically communicate only with computers from the same manufacturer. Each network used its own proprietary language or protocol to send information back and forth. Computer could typically communicate only with computers from the same manufacturer and unable to communicate with computer made by different manufacturer. So, there is a need for an international standard model. That's why OSI reference model comes into existence. What is OSI reference model? The OSI model is a conceptual model created by the International Organization for Standardization. It is a set of guidelines which enable different systems to communicate using standard protocols. For example, data transfer between a Unix host and a PC or a Mac. OSI model breaks down network function into 7 layers. The layers are known by their name or by their layers number. Each layers of OSI model is responsible for different parts of network communication process. These layers are application layer, presentation layer, session layer, transport layer, network layer, data link layer and physical layer. Application layer. It is the topmost layer of OSI model. It provides services that directly support user applications such as web browser, email, and web application app, etc. This is where user interact with the system directly. The presentation layer. It is responsible for translation, compression, and encryption. This layer is responsible for character set conversion, data encryption, data compression, interpretation of graphics commands, and so on. The session layer resides at layer 5 and manages the communication between the two endpoints is known as the connection. It is used to establish, manage, and terminate the session. A connection is established and maintained while the two endpoint applications are communicating back and forth in a conversation, or session, of some duration. The transport layer takes data from session layer and breaks it into segments on the transmitting end. It is responsible for reassembling the segments on the receiving end, turning it back into data that can be used by the session layer on the receiving end. The transport layer carries out flow control, sending data at a rate that matches the connection speed of the receiving device. Error control. Transport layer checks if data received at receiving end is error-free or not. If data received incorrectly at receiver end, it will request to send data again. Network layer is responsible for moving the packet from source to the destination. Layer 3 provides switching and routing technologies, creating logical paths, known as virtual circuits, for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as addressing, internetworking, error handling, congestion control and packet sequencing. Data link layer. This layer ensures that data will be delivered to the proper device on a LAN using hardware addressing. The data link layer, layer 2, of the OSI model actually consists of 2 sublayers, the media access control, MAC, sublayer and the logical link control, LLC, sublayer. The MAC sublayer controls device interaction. The LLC sublayer deals with addressing and multiplexing. Physical addressing for network connections exists at the data link layer. The data link layer combines data bits into entities called frames. The physical layer is responsible for the transmission of raw data over a physical medium, that is over cable, optical fiber, or wireless connection between network nodes. The raw data, which is simply a series of zeros and ones, while taking care of bit rate control. In networking model, the terms encapsulation and de-encapsulation refer to a process in which protocol information is added to the data and removed from the data when it passes through the layers. Protocol information can be added before and after the data. If information is added before the data, it is known as header. If information is added after the data, it is known as trailer. Header and trailer added by a layer in the sending computer can be removed only by the peer layer in the receiving computer. For example, header and trailer added by the transport layer in the sending computer can be removed only by the transport layer in the receiving computer. Thank you for watching. For more video, please subscribe to our YouTube channel. Join our online classes for CCNA/CCNP Advanced Routing.